All right, so work power and energy. Question 1. An object of mass 15 kg is pushed along a rough horizontal floor by a constant force of 70 newtons. So you can even get to visualize what the question is talking about. You have got this box which has got a mass of 15 kg. So you get to push it horizontally with a force of 70 newtons. Now the force, well, you don't apply it straight, you apply it at an angle of 20 degrees below the horizontal. So here is the horizontal here. So meaning that what are we doing here is pushed. So you are pushing below the horizontal. This is what is happening. Okay, the force is applied at this angle, which is 20 degrees from the horizontal, and that force is 70 newtons. If the box undergoes a displacement 5 meters to the right, meaning it gets to move only for 5 meters here, and the coefficient of kinetic friction is zero point 0.3, meaning that there is a force pulling it in the opposite direction, and you know the coefficient of kinetic friction as zero point 0.3. Then we want to find first the acceleration, the work done by all these forces which are listed down here. Now to start with the acceleration of this system, using Newton's second law of motion, we know that net force, this is going to be in the x direction because it's moving in the x for an object given by mass times acceleration. Now before then I'll say net force is given by the applied force in the x and then minus the friction force. In this case it's kinetic friction because this is moving. Now we know that net force is mass multiplied by acceleration. This is going to also be in the x, and this force in the x then is going to be F cos theta, because we are talking about the x component of the force that is going to be pushing this thing forward, because this force 70 newtons can be broken into components, and then that will be minus kinetic friction. You know that is given by coefficient of kinetic friction times normal force. A normal force on a horizontal floor is given by mass times gravity. Are we moving together? Have you gotten this part which I've written down here? Or maybe it had cut.
It had stopped on first consider.
Okay. So kinetic friction is given by coefficient of kinetic friction times normal force. But since this is a horizontal flow, the normal force is mass times gravity. Is that okay now?
Yes,
Okay, so just get now to substitute. The mass is 15 multiplied by the acceleration, that is going to be equal to applied force is 70 cosine of 20 minus coefficient of kinetic friction is zero point 0.3, mass is 15, gravity that is 9.8. So I'll simply punch what is over the other side, and the result I'm going to divide it by 15 for me to remain with the acceleration. If you have got a calculator, you can as well get to punch that. 70 cos 20, and then minus 0.3 multiplied by 15 multiplied by 9.8, and then divide that by 15. So that is going to give us an extension of 1.445 meters per second squared. Is this all right?
Yes.
Okay. Now the next one, we want to find the work done by the applied force. How do you get to find work?
Work is equal to force times distance.
Force times distance. So the work done by the applied force is going to be equal to force times distance. And the force, this should be in the direction which goes in the same, which is in other words parallel to the distance. So that is x component of the force. That is going to be 70 cos 20. And then now you multiply that by a 5. 70 cos 20 times 5. So this is giving me 70 cos 20 times 5. Okay, that is giving me 328.89 joules. Since this is work, it's going to be found in joules. This is cool.
Yes.
Okay, the next one, we want to find the work done by the friction. So work done by friction, then is going to be friction times displacement. Okay. Now, when you're talking about the displacement, you talk about displacement cos theta. You need to look at the angle that the force is making with the displacement. So if you look at the applied force and the displacement, they are going in the same direction. The angle they are making is 0. Cosine of 0 is 1. But if you look at friction and displacement, they are going in opposite directions. So if I put cosine of theta here, meaning that cosine, the angle between these two is 180 degrees. So then cosine of 180 is negative 1. That is why work done by friction is negative. It always gets to subtract. So this is going to be negative. The friction itself is given by coefficient of kinetic friction, which is given by 0.3 times mass, which is 15, times gravity, which is 9.8, and then you multiply that by a distance moved, which is 5, because these are going in opposite directions. So 0.3 times 15 times 9.8 times 5. This is going to give us negative 220.5 joules. We are good.
Yes.
The next one, we want to find the force done by gravity. Now, when you are finding, the work done by gravity, when you are finding work is given as force multiplied by the distance going in the direction of the force. So if you multiply gravity times the distance moved, you can say gravity goes down and then the distance is going in that direction. So if you say cosine theta, the angle between these two is 90 degrees, and cosine of 90 is 0. So 0 times anything will be 0. So work done by gravity and work done by the normal force is always 0 in this case. Because also the normal force goes up. The distance is going in this direction. You're still making 90 degrees there. Cosine of 90 is still 0. So that is why work done by gravity and normal force is 0. Is that okay?
Yes.
Okay, we also want to find the work done by the net force. Now we know that net force is the applied force, which is 70 cosine of 20 minus the friction force. And the friction force is 0.3 multiplied by 15 multiplied by 9.8. So let's get that. 70 cos 20. The answer we get minus 0.3 multiplied by 15 multiplied by 9.8. So this is going to give us 21.6784 newtons as the applied force. Meaning that the work, or I mean the net force, work done by the net force is going to be equal to net force multiplied by the displacement. Since the net force is positive, meaning that it will be going in the same direction as the displacement. So that will just be 21.678 multiplied by the displacement, which is 5. And that is going to give us 108.39 newtons as the work done by the displacement. Okay, consider question 2. An applied force varies with position as f of x is equal to 3x squared minus 5 newtons. Where x is in meters, how much work is done on the object as it moves from x, which is equal to 4, to x, which is equal to 7. Now, at this position, where it is at x is equal to 4. So what will be the work done? That is 3 multiplied by 4 squared, then minus 5. So 4 squared is 16. 16 times 3 is a 48. 48 minus 5 is a 43. So this is the work done at this position, 43. I mean, that is the force at that point. Okay, is 43 newtons. And then we can also find the force at the position 7 meters, and that will also be 3 multiplied by 7 squared minus 5. And this is going to give us 7 squared, we know that is 49. And 49 times 3, 147 minus 5, that is going to be 142 newtons. Okay, so this is what we have. So how much work is done on the objects as it moves from x is equal to 4 to x is equal to 7? And we know that work is given by force multiplied by distance, right? So at this position x is equal to 4, the force which is there from what we are able to see is given by this equation. And then at the, I mean, is given as 43, that is the force which we are getting to apply when we are at position x is equal to 4. And then at 7, we have got 142. So we can find the work at position 4, and that will be equal to force, which is 43, multiplied by the distance, which is 4. 43 times 4, and that is going to give us 172 as the work. And then the work at the position 7, 7 force times distance. Now the force is 142 multiplied by the distance, which is 7. 142 by 7, that is going to give us 994. Now you want the work done to move from this position to this position. So therefore work is going to be 994 minus 172. And that is 822 joules. Is this fine?
Yes.
Okay. So question 3. A force of 6I minus 2J newtons acts on a particle which undergoes a displacement of 3I plus J meters. Find the work done by the force on the particle. Now you know that work is given by force multiplied by distance. So when you are dealing with vectors, then it will be force multiplied by distance. Don't use a cross, use a dot. because what you are going to perform is a dot product. It's different from the cross product. So the force here is 6I minus 2J dot product with a 3I plus J. When you're performing the dot product, you just multiply similar terms. So the one with I this side multiply with the I that side. So 6 times the 3, you just multiply coefficients because I times I is 1. I times J on the dot product is 0. That's why you don't multiply those which are different. So 6 times the 3, that is 18. Negative 2 times 1, which is the coefficient of J, is negative 2. Meaning that the work done here is 16 joules. And then you also want to calculate the angle between the force and the displacement. That one we're also going to use the principle that comes from the dot product when you are finding the angle. So cosine of theta is given by A dot B divided by the magnitude of A multiplied by the magnitude of B. So then this is going to give us the dot product. We've already seen that is 16. So the magnitude of A. So just get 6, you square it, plus get a negative 2, you square it, and then you square root the answer. And then here get 3, you square it, plus get 1, you square it, and then you square root the answer. 6 squared is 36, 2 squared is 4. So 36 plus 4, that is a 40. And 40 is the same as 4 times 10. So meaning that square root of 4, you know that is 2. So this is 2 square root of 10, and then multiplied by 3 squared is 9, 1 squared is 1. So that is going to give us a 10. So that is square root of 10. We know 10 times square root of 10 times square root of 10 is a 10 times 2, that will give us a 20. So that will be 16 over 20. Therefore, if we want to remain with theta, we're going to take the cosine inverse of 16 over 20. We know 4 can go into 16 4 times, 4 into 20 5 times. So cosine inverse of 4 over 5, that is going to give us a 36.9 degrees. Is that okay?
Yes.
Okay. Okay, question 4. Water is being raised by a pump from a storage tank 4 meters below the ground. So you get to bring it 4 meters from below the ground and delivered at 8 meters per second. So the rate of delivery for the water is 8 meters per second through a pipe at ground level. So I mean that it is just at the bottom here. If the cross section area of the pipe is 0.12 square meters, that is the area. Okay. Find the work done per second by the pump. We've also been told that 1 cubic meter of water has a mass of 1000 kg. 1 cubic meter of water has a mass of 1000 kg. Now, from what we have, it is coming from a height of 4 meters delivered at a rate of 8 meters per second through a pipe at ground level. Now the area of the pipe is 0.12 square meter. Find the work done. Okay, if the cross sectional area of the pipe is 0.1, find the work done per second by the pump. 1 cubic meter of water has a mass of 1000 kg. Now, all we want to do, if we want to find the work which is done by the pump per second, we already know the unit for work, right? Work is given in what?
Joules.
What is the equivalent for joule? So we know that work is given by force times distance, which is a Newton meter. So we need to find something in the term Newton meter. Now here we are saying work done per second. So Newton meter per second, that is the unit that we want to have at the end. So already here we have got meter per second. So we are remaining with a Newton, right? So one thing that we've been told here is that the area of the palm pipe is 0.12. Okay, so if I want to have Newton meter, meaning that I'm supposed to multiply by the area is 0.12. So if I get to multiply by 0.12, we are going to have meters squared. Meters squared times this meter, we're going to end up with meters cubed. But let me first start with the relationship that has been given with the mass for water. Okay, so from what you've been told, 1 cubic meter of water has a mass of 1000 kg. 1 cubic meter of water has a mass of 1000 kg. Now, how much mass of water is going to be here? We know that 1 meter cubed is equal to, or actually here what we have is a square meter. Square meter, meaning this is the area. Now we want the volume. So the first thing is we need to find the volume of the pipe. The volume of the pipe. And volume is given by area multiplied by height or multiplied by distance. So the area is 0.12. The distance of the pipe, they've already told us that is 4 meters. So 0.12 multiplied by 4, that is going to give us 0.48. This is the area in cubic meters. Now, I'm going to multiply this area in cubic meters. I'm going to put a cubic meters down. I want to have a kg on top. Now what you've been told is 1000 kilograms has got 1 cubic centimeter. This is from here. I mean 1 cubic meter is equal to 1000 kg, meaning that 1000 kg is 1 cubic meter. So the cubic meter cancels with the cubic meter. If we get to multiply 0.48 by 1000, we are going to get 480 kg. So this is the mass of water that is flowing from the pump. Is that okay?
Yes.
Okay. So I'm going to multiply by the mass of water, which is 480 kg. So this is going to be in meter kg per second, but we want meter newton per second or newton meter per second. So the question is, how do I convert the mass of water from kg to newtons? What do you think? How do you convert from kg to newtons? Have you understood the question?
Yes.
Yes. How can you convert kg to newton? You already know. We already know how to convert mass to weight. How do you convert mass to weight? Weight is mass times gravity. So if I want to convert this value, which is mass, into weight, we know that weight is in newtons. Okay, simply multiply by gravity. So gravity is 9.8 newton per meter squared, isn't it? Newton per meter squared. But I can just, from what you already know, is it even newton per meter squared or newton per kg? Newton per kg. Because it can either be newton per kg or meter per second squared when you're using it as acceleration. So what we are saying is that in 1 kg, we have got 9.8 newtons from the value of gravity. So this kg will cancel with the kg. Then the answer is going to be 8 multiplied by 8 multiplied by 480 and then multiplied by 9.8. This is going to give us 37632. This is going to be in Newton meter per second, which is joule per second, because we know that a Newton meter is a joule. Is this okay?
Yes.
Okay. Some things you not have a definite equation that you have to use. That is why the first topic is units and measurements to do with dimension analysis. You can make derive equations if you just know the dimensions of something. Okay, question 5. Question 5. A train of mass 200 tons moves with a constant speed of 72 kilometers per hour up an inclined hill when the engine is working at 800 kilowatt. Find the resistance to the motion of the train. Sine theta is 1 over 50. Okay, so we have a train which is moving, a train of mass 200 ton moving with a constant speed of 72 up an inclined hill. So it's going up an inclined hill, something like that. So from what you have been given is that sine theta is 1 over 50. You know that sine is given by opposite over hypotenuse. Okay, so meaning that the opposite is 1, that's the height, and then the hypotenuse, the distance covered, is 50. We are going to take this in meters then. Okay, like that. So we have got a train which is here having that mass. Now the thing is, it is moving with constant speed. What do you know about constant speed?
The acceleration is zero.
The acceleration is equal to 0, right? Yes. Okay, a constant speed of 72 up an inclined hill when the engine is working at 80 kilowatts. So what unit is this? It's a unit for what? For what quantity?
Power.
So this is a unit for power. A watt is a unit for power. Okay. So you can actually convert to watts from the kilowatts, which is going to be 800,000 watts. Okay. And we know that power is given as work over time. At the same time, we know that work is force times distance over time. And we also know that distance over time gives us velocity. So power is force times velocity. Okay. So the power we've been given is 800,000. That is equal to the force applied, we don't know. But the velocity is 72 kilometers per hour. Now we need to convert to the right unit. 72 kilometers per hour. Multiply. We'll take a kilometer down and then a meter on top. Are we moving together?
It has stopped showing on the board.
Okay. Is it showing now?
Yes,
Okay. So we know that in 1 kilometer we have got 1,000 meters, and then since a kilometer per hour we have got an hour down, I'm going to put an hour on top. Then a second down, and we know that in 1 hour I've got 3,600 seconds. So the hour cancels with the hour here. Kilometer also cancels with the kilometer there. So it's going to be 72 multiplied by 1,000 and then divided by 3,600. This is going to be 20 meters per second, and that's the one you use, 20. Meaning that the force here is going to be, this 0 can go with 1 0 here, 2 into 8, that is going to be a 4. So this is going to be 40,000 newtons force. Find the resistance to the motion of the train. So this is the force that is pushing it up. That's the force pushing it up. Now, if we take it that on this motion, we don't have, uh, actually, this force that we're able to see here, since we have said power is work over time, this force that we use is pushing it up. That is the power generated by the engine, but there is going to be some force which is pulling this behind. Think of this. For this thing to be able to move up, the first thing that would have happened is that it has overcome friction. Okay, like that is why it is moving at a constant speed. So the take note of this. This is very important. The only way something will be moving at a constant speed is that we are considering that the forces are already balanced. The forward force and the backward force are already balanced. So we've already subtracted the backward force. So actually this force that I found here is the net force. Okay, that's the net force. You know that net force is given by applied force minus some frictional forces in that case. Net force is given by the applied force minus friction forces. So another thing that we could have used for this one to find the resistance, we could have used the work energy theorem. Work is equal to change in kinetic energy. Work is equal to change in kinetic energy. Now, because we know that there is no change in kinetic energy because we have got a constant speed. Okay, if we have got constant speed, it means there is no change in kinetic energy. So work is going to be given as just force multiplied by distance, and that is going to be equal to change in kinetic energy, which is equal to 0. Now, this force that we are talking about should be the net force because you are considering the upward forces minus the downward forces if we know the applied force at this position. But since this force which we have found, remember it is uh, the engine is working at this power. It is the engine working at this power, meaning that this is the force which the engine is applying. I'm not going to even call it the net force because that is the power at which the engine is working, and so that is the force at which the engine is also pushing up. Okay, and if we consider now net force is given by applied force minus any frictional forces, and because this is constant speed, meaning that net force is mass times acceleration is going to be 0, and so applied force, which is for 40,000 minus friction, they are going to be the same. So the applied force and the friction, they've already balanced each other. Now, this is not, we are not just talking about kinetic friction as the only friction here. Remember, when something is going up an incline, there is also Fg, which acts as a friction. Okay. So just the total resistance acting, because here we just have the question to say resistance. They've not told us what kind of friction. If they said kinetic friction, I would have removed the Fg because it is also a force which gets to put down. I don't know if that is okay.
And
Okay. So question number 6. Ball 1 has mass m and is moving at 5 meters per second. It collides with ball 2 of mass 2 of mass 2. Is this correct? Of mass 2, 2 meters. They should have a mistake. So ball 1 has a mass m. Okay, this is 2m. This is not the unit. It's just talking about being the mass twice the mass of the first one. So it's okay. So ball 2 is at rest. So we can just depict what is happening. You have got this ball which has got a mass of m, which is moving at 5 meters per second. It gets to hit this one with a mass of 2m, which is at rest. After collision, ball 1 has a velocity of 2 meters per second at an angle of 50 relative to the original direction. So here is the motion which is happening. So this one bounces like that. So this one is going to go up 50 degrees, and it has got a velocity of 2 meters per second. This is ball 1 which has got a mass of m. Have you already started doing momentum?
Not yet.
So this is momentum. Then we are going to answer this question when I start. Okay, next time in physics I'll start teaching momentum. Is there anything else that has to be explained on work power and